Now we're going to learn how to solve for exponential equations using logarithms. Now logarithm, let me highlight it here in question number 5, an instruction for number 5. We're going to use logarithm. When we write logarithm, we abbreviate it as log, L-O-G. So notice how questions 1 through 4, you guys have log. Now, logarithms is basically the way we're going to solve an exponent. Now, let me break this thing down. So this number by itself will always be the exponent. Again, logarithms are used to solve for exponent. And this little thing right here, we're going to call it base. In this case, it's going to be base x. And my exponent is y. Okay. Now, if I don't write anything for the base, if I leave that blank, we're going to say our base is 10. So if there's nothing for x there, like instead of an x, it was empty, it was just blank, I'm going to say the base is 10. Okay. So again, when we don't use the log, when we don't write the base is 10. Now, the way I'm going to write this in exponential form, right? Because it says rewrite each equation in exponential form. I'm expecting to write it with an exponent. And I'm going to write this as x to the y, because notice how the base is x, the exponent is y. So I'm going to write this as x to the y equals 164. You guys see where the 164 comes from. That's it. That's all I'm going to write. Let's take a look at question number 2. The base. Identify the base. Remember, the base is this little thing right here, base. And again, if it's that space is blank, my base is 10. My exponent is this thing at the end by itself. So to begin with, I'm going to write b to the 18th equals, in this case, I'm going to let 164. Question number 3. Identify the base, right? The base in this case is right here. And -1 is my exponent. So I'm going to write 4 to the -1 equals 1/4. Lastly, question number 4. Right, look at the base, look at the exponent. Let me just write this as n to the m. Because remember, the base is n, the exponent is m. So n to the m equals 97. So that's the first part, writing from logs to exponent. And if I don't write anything for the base, remember, it's 10. Now there is a special log. We call it natural log, but we're going to spell that as ln. Let's say ln, and then I said of x equals 3. Okay, I don't see anything for the base here. The base for natural log will always be the letter E. It's a number. E is actually a number. It's about 2.7. It's after Euler. We spell that E-U-L-E-R. So E is after Euler. Now the base, like I said, is not there, but let me just write it down for right now. It's going to be E. So this one I will write as E to the 3rd. It's equal to X. Now, if I was just to write something like log and say this is X and 3, so now I don't see a base for this log. If I don't see a number, the base is 10. So I'll write this as 10 to the 3rd. It's equal to X. So be careful on those two, okay? Now let's take a look at question number 5 through 8. Given to us as an exponential function, or exponential form, right? It looks like an exponent. I see v to the u, so it looks like an exponent, but I need to rewrite this in logarithm form. So kind of like how questions 1 through 4 were. So I'm just gonna write log base V of 25 over 48, it's equal to U. Because remember, at the very end, I should have my exponent. Logarithms are created to solve for the exponent. So whatever I have after the equal sign is the exponent. My base was V, so I said log base V. All right, question number 6, I'm gonna write this as log. The base in this case is K. So log base K of 152 is equal to -1. Here I'm gonna write this as log base X of Y equals 20. Again, as a reminder, what I have at the very, very end by itself, after the equal sign, is the exponent. So from the get-go, I know here I'm going to have equals to 2, right, at the very end. So let me write this as log base 12 of 144 is equal to 2.